This is the 8th year we've brought University of Washington students to Peru. Both Ursula and I love working with students in this environment, and we love seeing the impact that this course has on our students, both as far as their love of biology and the sustainability ethic that they take home with them after being in some quite challenging places, both culturally and environmentally and ecologically. This is not an easy place to be by any means. These are the things that you experience when you're out here, and sometimes you just have to take a break and just remember where you are, and remember that the wildlife just comes and goes, and you're in their place. So this is one of the most immersive field courses that the University of Washington offers.
Okay, my name is Ursula Valdez. I'm a Peruvian ecologist. I'm a faculty now at the University of Washington, Bethel, and we're happy to be part of the community. A course like this not only gives you opportunities to be able to, measure the level again of herbivore, you can actually come up with a question about what is it doing, and then come to the field. So first of all, field skills are something that not everybody gains. We learn in many ways, and I think the best way to learn is by doing. And if we want to kind of train scientists, you want to give them the tools to think as a scientist, and you wanted to give them the opportunities to come up with the questions into within a living system with a real world. So students gain the opportunity to, first of all, seeing nature with different eyes, feeling nature with different eyes, and then get stimulated by that. And one of the main things I think that is very important for me is how you make them so curious about, simple daily actions that nature is just doing, right? So if you're curious about it, then you're going to start asking questions. And if you come out with a question, you can come out with a hypothesis. And if you come out with a hypothesis, let's test it. Let's collect data. Let's see what's going on. And if you don't find anything, let's try it again. So that's the whole purpose, to kind of gain the skills on testing hypotheses, thinking on your own with an element that is in front of you. Or maybe it's not that obvious, but then by doing it, you may come up with a question, with a different answer, and then that will create another question, and so on. Then you have the ability for people to be independent about doing some project on their own. They generate their own ideas. It's no longer what I thought, it's what they think. And I think that's so important that students think on their own. Another thing that I think is pretty important is that the students get out of the context. You kind of have a completely different experience being out of your comfort zone, out of your daily element, and just kind of give you an opportunity to be in a different place that stimulates you differently. And I think that's also important. Another skill that is really great to gain within an experience like this is that the teamwork, what you guys are doing, collaborating in a real project, struggling every single day, dealing with the frustration. It's no longer about getting everything perfect, finding answers in your cell phone, finding answers in Google, trying to figure out. You're struggling with real issues, and you're struggling with just the limitations that a place like this has. You don't have too much access to the world. That's going to make you think much sharp about something. You're going to try to find a solution, and I think that's important too, to deal with difficulties, deal with challenges. I mean, it's hot here. You're not physiologically, you're not adapt to this, but you're gonna make it, and you're gonna deal with it. And at the end of the experience, you'll feel empowered, you'll feel stronger. That's part of the things that we want you guys to gain. And then, obviously, is this sense of being in a place like this. I want to see those things. Exactly what I was just talking about before, right? We are in the middle of a conversation and suddenly something happens, something shows up. One of the most fantastic opportunities to see a troop of capuchin monkeys. I mean, we saw like about 25 within like a few minutes, and it just gives you the opportunity to see them in action. So it's great to be in a place like this, in which you walk around and just can see all these things happening the same way that have been happening for 100 years, for 200 years, for millennia. It's just kind of a living laboratory of like, ecology, evolution, everything together within your eyes. So why not giving the students the opportunity to come here, right?
Mm-hmm.
It's an excellent reason. So that's why we do this.
Awesome.
Cool.
We are looking at the diversity of species of fungi in an old growth forest versus a successional forest. Yeah. So what we're doing is every day we set up 5 by 5 meter plots. Right now we're in the old growth forest, and we set up the plot and see how many fungi we can find, and what we're really comparing is the diversity between the forests. So we're trying to know how many species, or we can call them morphospecies because we don't really know what they are. But for example, when we find a fungus, woohoo, right here, we note what form it's in. So this one has a stalk and a cap and what it's growing out of. For example, the ground, often they grow on dead wood like logs. And for every plot we note the canopy cover level and the soil moisture and
the amount of dead wood that's around.
Percent of dead wood on the ground.
And then we also just take a picture of the fungi so we can later on examine it and draw pictures of it and just kind of keep like a sort of catalog of the fungi.
We're looking for fungi about the size of a button or larger. If they're any smaller than that and happen to be in clusters that are 2 centimeters apart, then we're just counting individual clusters.
Well, we're looking at bird populations here in the Cocha Cashu field station, and we're looking at different altitudes at which they're flying to determine whether or not their body composition has an effect on their altitude while they're going along the forest floor.
So our hypothesis is the more compact the bird is, the lower it's going to be on the net.
So we're taking a total of 5 mist nets, and we are setting them up in certain areas, and once we capture the birds, we're going to be taking measurements and writing down their morphological characteristics.
Perfect. How's it going today?
Well, we got a little washed out today. It's been kind of thunder and lightning here, so we had to move our mist nets a little bit. Can't really capture the birds while it's raining. Get injured, and it's really kind of a muggy business. So we're going to wait until the rain clears up, and hopefully does that soon so we can start getting our data.
Mm-hmm. Cool. Yeah, we conducted 3 30-minute surveys today, and each one of them turned up no birds before we got rained out.
Cool.
Yeah.
Thank you. Anything to add?
The rain stopped. We can do our research this afternoon.
Awesome. Thank you.
Stays that way.
So we are the Heliconia group, and we are studying the density of Heliconia and Marantaceae in relation to light. And then we're also looking at the different floral stages to see if they can coexist. Like if they flower at different stages, maybe that indicates that they exist at the same time.
Yeah, and so basically what we think is going to happen, since we're starting and we are looking at the effects of light, we think that there'll be more Heliconia in areas with highlight, and then as you go further into a canopy, there'll be more Marantaceae, because Marantaceae are more shade tolerant than Heliconia. We're looking at the flowering stages, kind of what Carrie talked about, to see if they'll coexist or if there's competition for pollinators. And so far we've only seen Heliconia flowering, so that might indicate that they have different flowering times, so that's why they're able to kind of coexist in patches like you see behind us. So
great. And then what are your methods for finding out?
in terms of our experimental design, we're setting up transects. We're planning on doing 10 in each location. So we have one location by the lake,
and then one location by the river, and we're going to compare those two, and we're setting up transects that run perpendicular to the body of water. So we start as close as possible to the water as we can, and then we run our transect back. We take measurements and plots of 2 by 2 meters, and we count the density and all the different characteristics in each plot.
Great.
We're looking at the abundance and diversity of beetles around fig trees, and we propose, I guess, that as we get further away from the tree and outside of the range of fruit fall, we'll find less beetles in abundance and a less diverse community.
How's that going?
It's going hard. We got a few seeds here. Trying to figure out which one, if this is a fig tree or not. But
They're not.
It's not. But this one is, I believe.
And then we have these other, let me find them, these other fig berries or fig fruits from a different species.
Rivers don't stand still, and the Manu River behind me is no exception. Over courses of centuries, they meander their way through the forest, changing the topography of the area, which has a direct influence on the vast biodiversity found here. As rivers meander, eventually they take the path of least resistance, cutting channels off and turning them into oxbow lakes like we have here, the Cocha Cashu.
Some of the largest trees in the world occur here in tropical rainforests. They develop these wide buttress roots which help provide stability so that the massive tree doesn't topple over due to its size. These roots also serve another purpose, collecting as many nutrients as possible from the thin topsoil layer that typically occurs in tropical rainforests.